Hello and welcome to the final video in this series on parametric equations. Parametric equations does come up a little bit more in the second year of the A-level maths, but for now this kind of playlist and this set of videos is just going to focus on the basics. So what this last section is about modelling. So because parametric equations can be used to draw and visualize a far wider range of graphs that a Cartesian system can manage, it allows us to model much more complicated and more detailed mathematical problems. So the example we're going to look at now in this video focuses on modelling the path of a roller coaster. So if you've ever been to Thorpe Park or Alton Towers in the UK, you can see we've got this kind of steep drop. So we have this path of a roller coaster given by parametric equations, 5 plus ln t and y equals 5 sine 2t. And we've got a few questions here. So we want to find the coordinates of the point where t is pi over 2. Nice and simple. So all we're going to do, when t is pi over 2, x equals 5 plus ln pi over 2, which is going to be some very unpleasant number. We can see there 5.45. Okay, then y is 5 sine 2t, or 2 pi over 2. And now you should be able to guess, even without calculating, just from the looking at the graph, that this is going to be 0. If you're worried, check, make sure you're in radians mode. 5 sine pi is indeed 0. So that's all right. So, looking at the wording of this question, given that 1 unit on the model represents 5 meters in real life, find the maximum height of the roller coaster. So this question is a little bit... Students could make this more complicated than it needs to be, because they see maximum height and they think, okay, great, maximum y, maximum, need to differentiate. Which is fine, you can do it that way, but if we stop and think about it, this is actually a relatively simple question. We can see here the maximum height is when the y coordinate is biggest. So the maximum height is when we have the maximum y value. Looking at our equation, we have 5 sine 2t. The maximum value of this is very straightforward, because the maximum value of sine 2t is 1, so the maximum value of y is 5. So therefore the maximum height is 25 meters, because 1 meter, or 1 unit, is 5 meters in real life. So finding the horizontal distance covered during the descent, so thinking about it, we've got to find this distance travelled. So not through the whole thing, just in when it's going down. So first we need to figure out the t value here. But we know that that's when sine 2t is 1, because y is 5. Which tells us that 2t is pi over 2, so t is pi over 4. Now in this case, quite likely t represents time. So after pi over 4 seconds, that's when we're at the top. Possibly, we don't know, but it could be that kind of thing. So this is a really nice, this is why quite often for things like roller coasters, buildings, mechanical things, parametric equations will be used, because you can graph distances in two different directions according to a third parameter, maybe time. But anyway, so therefore x is 5 plus ln pi over 4, which is again going to be a very unpleasant number, 4.758. We want to know the distance travelled in this bit. We know the end. So therefore, the horizontal distance during descent is going to be the distance at the end, which was 5.45, minus this. Surely. But hang on a minute. That's just the difference in x. That's not the horizontal distance. Remember, 1 unit on the graph is 5 meters in real life. So we just stick this in our calculator and we get 3.46 meters. So we travel 25 meters down and 3.46 meters across. So here, find the average gradient. Now, again, I know gradient typically means dy by dx, but the really important bit is this, average gradient. Which means we're approximating this curve as a straight line. So the average gradient is just going to be change in y. So because I didn't work out this x bit specifically, I'm going to have to use this 25 over 3.46. Now again, very easy mistake to make here. This looks fine, change in y over change in x, sorted, but we're going down. So it needs to be minus. Whack that in our calculator, and we get minus 7.23. And that's basic modelling. On the whole, it's just, like all modelling, it's just using the maths you know for the specific real-life situation you're trying to solve. Now, modelling with parametrics goes way beyond looking at what a roller coaster can do. Something that we do in further maths is we introduce additional parameters to find things like predator-prey models, or at kind of very, very high levels, you can use this to try and measure chaos and things like that in a system. Physicists and astronomers may use this for modeling stellar movements or interstellar movements and things like that, because again, you can measure distances in 2 dimensions and compare them at the same time to something like time. So that's it for the week of parametrics, or for this set of parametric videos. Thank you very much for watching, and I'll speak to you soon.